2j minus 3, so the truss becomes unstable. If you talk of the third case, that is figure C, then you have 6 number of members, 1, 2, 3, 4, 5 and 6 members, and the number of joints are 1, 2, 3 and 4, and the equation becomes m is greater than 2j minus 3, and therefore the truss is statically indeterminate or stable. Now if I want to create or make this truss to be a stable truss, how do I do it, or how do I consider whether this truss is a stable truss, which we will be looking into the next thing. If you see here, the number of joints very clearly are shown as 6, and then the total number of members are 10. So if I talk of the equation m equal to 2j minus 3, it is not satisfying because m is not equal to 2j minus 3, and this will be considered as a unstable truss. But only thing is, if I remove one member, that is if I have removed member BE, I have converted this truss into a stable truss with 6 number of joints and 9 number of members, which satisfies my equation of m equal to 2j minus 3, or the equation of 2j equal to m plus 3. So this is a stable truss. Now what have I done is, basically I have removed only one member, that is a member at member BE. The next condition to be looked into is the support reactions or conditions of equilibrium, which we have already gone through, that is summation fx is equal to 0 and summation fy equal to 0. We are not considering summation m equal to 0 here, because until unless required we will not be using summation m equal to 0, and we have to find out these equations or summations and equate them to be a 0 value in x direction and y direction, that is horizontal components of all forces and vertical component of all forces. Now before we go into an actual truss solving, you need to know some basic concepts of trigonometry, though you have revised these in your 12th. I am basically only revising this for a very short duration of time. That is, I have a perfectly right angle triangle having sides A, B and C, with one of the angles, that is angle formed by joints AB, is a 90-degree angle. Then between C and B is theta 1, and between A and C is theta 2. Why do I require this? Is if I want to find out the length of C, that is joint C or member C, then C is given as root of a square plus b square, which is a famous Pythagoras theorem given by a great mathematician. And if I want to find out theta 1 and theta 2 after finding out the value of C, then how do I find those out? So if I look into this, the sine of an angle, that is abbreviated as SIN only, is defined as the length of the opposite side divided by the length of the hypotenuse. For example, sine theta 1 is equal to opposite side, that is A, divided by the hypotenuse, that is C. So if I want to find out sine theta 1, I divide the value of A with value of C. Now what is to be looked into here is, when you are solving it on your calculator, the most important thing which you all forget out is to see whether your calculator is in your degree mode or not. So sometimes if your calculator is in your radian mode, then what goes wrong is, whatever value you are getting is directly used by you in the degree mode afterwards, which will give you a wrong answer every time. So whenever solving trigonometry examples or solving truss or for MOS, always remember that your calculator is in your degree mode only, and only then start solving it. If you want to take the cos of the function, cos is given as the adjacent side divided by the hypotenuse. So sine of theta 1 becomes b upon c. Similarly, if I talk of finding out sine of theta 2, in this case sine of theta 2 becomes opposite side, that is b upon c. So if you see here, that same is being used for cos theta 1. So sine of theta 1 is equal to cos of theta 2, or the other way round can be used. Now we have looked into the length part. Now if I want to find out the components of a vector, which we will be actually doing when we are solving a truss, then I have to look into two things, that is the magnitude of the vector and the direction of the vector. Now here I am considering that the direction of the vector is with respect to the positive x-axis and going in anti-clockwise direction. You can take clockwise direction or with respect to y-axis also, negative x-axis or positive x-axis, negative y-axis or positive y-axis. Either ways you have to look into the same phenomena what I am teaching you here. If you take this vector, that is a force F equal to 20 Newton with a angle of 50 degree with the positive x-axis in the anti-clockwise direction. So I can break up this vector into two components of these forces, that is Fx and Fy. Now if I want to find out Fx and Fy, I need to know theta and know the magnitude of this force. So if you look into this example, Fy will be equal to, that is opposite side. So opposite side is always equal to the sine of this angle. So F into sine of theta 1, and similarly Fx will be equal to F into cos of theta. Now if I have a member which is inclined, and if I want to find out the value of those, then in that case I will be using sine of theta is equal to opposite upon hypotenuse, what we have already seen. But in this case, instead of replacing the length, we are using the force in that direction, that is Fy, divided by the total force, which is here the hypotenuse of the triangle, and therefore we will get Fy is equal to F of sine of theta. Similarly, if I want to find out cos theta, it will be adjacent upon hypotenuse, which is equal to Fx upon F, which will be Fx equal to F of cos theta. Now with this introduction, we will move on to solving an actual truss. So what has been given is loads are as shown in your figure, and we want to find out what are the forces in each of these members. So you have a horizontal force of 600 Newton at point D, and a horizontal force of 900 Newton at point E, and you have the truss as shown in your figure. Now first I need to check whether I have any zero force members or not, and then I will be drawing my free body diagrams at pin D and at pin E. Now if you see at point C, I have at point C no reaction and no external force. So that becomes that member CE, this member CE is a zero force member. Why am I not considering CB or CD? Is because B is again a support, and at point D I have a force of 600 Newton. So member CD or member CB cannot be a zero force member. Similarly, EB cannot be a zero force member because there is a load being applied at point E and a support reaction at point B. So out of these members, only member EC is a member which is a zero force member. Now drawing a FBD at point D, I am getting this, that is I have a 600 Newton force horizontal. Then I have a member DC which is at 26.57. How do I get that? Is by finding out the angles with respect to this length. Now because this is 2 meter, this length automatically becomes 1 meter, and this height is 2 meter, from which I have found out this angle 26.57 degree. Another force which is being applied is force FD. Now assume that force FCD is going towards the joint or towards the point D, and force FDE is going away from the joint. So in that case, if I apply my summation Fx equal to 0, where I am taking force going from my left towards the right to be positive, then I have 600 minus the component of this. Now see, I am taking the component of this in this direction, but my angle is with respect to the vertical, so I have sine component here. So it becomes 600 Newton minus FCD sine of 26.57. Why? Because this is going towards, so my vertical component will be going upward and horizontal component will be going from right to left, not from left to right. Because I am assuming it to be going towards the point, the horizontal component is becoming going from right to left, which is opposite to 600. Therefore I have put in a minus sign here. So I have to equate this equation to be equal to 0, from which I will get FCD is equal to 1341 Newton or 1.34 kilonewton under compression. Now again what is to be seen is FCD will be equal to FBC or not. Now the next equation I am doing is summation Fy equal to 0 or summation V equal to 0, wherein I have assumed my force is going from bottom towards the top to be positive and the forces in the opposite direction to be negative. Now again here we can see at point D we have how many forces being applied. One force is FDE and another force will be the vertical component of this force FCD. Now we already seen that for FCD the force component is going upward, that is for FCD if I want to find out my vertical component, it is going upward, and whereas my force FD is going downward. So I have written my equation as 1341 cos 26.57 minus FDE is equal to 0. Now again remember FCD is going upward and I have considered upward going forces to be positive as shown here, and FDE is going downward, which I have considered as negative. So I have put in a negative sign here, and which will give you FDE equal to 1200 Newton, that is tension. What is to be seen here is both these values what we have achieved are positive, which means whatever directions which we have assumed here are correct, and these values are to be taken up as they are, and no direction change is to be provided onto joint D. Now if we look at joint E, at joint E we have first a member which is ED, that is FDE force going upward. Then we have another force which is EA, which I have assumed as going downward. I have a force 900 Newton coming from left towards the right, and I have a member FEB, which is at an angle of 45 degree. Now how do I say 45 degree? This is 2 meters, this is 2 meters. So you can, if you want to find out the angle, this angle is 90 degree, this length is equal to this length, so these angle and this angle will be the same. Is basically simple trigonometry. So this is 45 degrees which I have given here, and I have assumed this force to be going towards the joint. Now I again solve this joint for summation fx equal to 0 and summation fy equal to 0. Now if I talk of the horizontal forces, I have a horizontal force 900 Newton again going from left towards the right, therefore I have written it as positive. And what is the next component of horizontal force is FEB, that is the horizontal component of force FEB. Again the angle is with respect to vertical, so my horizontal component becomes the sine component, FEB sine 45, again in the opposite direction. If you see here, even if you write cos 45 here, the answer will come out to be the same, but your step will be considered to be wrong because you do not understand what is trigonometry in this case. So always remember, whatever is the angle with whatever axis it is given with, that component becomes the cos component, the perpendicular component becomes the sine component. So I have taken here 900 minus FEB sine of 45 degree equal to 0, from which I get FEB equal to 1273 Newton, which is equal to 1.27 kilonewton in compression. Again, why do I say compression? Because whatever I have assumed, I have got a positive answer, so my assumed direction is correct. The second equation to be written is for summation Fy, again considering going upward to be positive. What is going upward is the force FDE, which we already found out to be 1200 Newton. So I have taken that as positive. Next, FEB, the cos component of FEB or the vertical component of FEB is again going upward. So that is to be also added to the equation, and only FEA is what is going downwards. So I have taken that as negative, from which I will get FEA equal to 2100 Newton. Again the value is coming out to be positive. That means my assumed direction is correct. This is another example where you can see your truss is cantilever from 2 points. You have joints at 2 points, that is at point E and at point D. In such cases where you have a cantilever section, it is always preferable that you start solving your truss from the cantilever point, because in that case you will always have only 2 members which are unknown here, because the force going downward is known to you. So first of all I need to find out the support reactions, and in that case I have taken moment about point E. Now if I take moment about point E, then I have 330 kilonewton into total 10 meters going in clockwise direction, which I have taken as negative. Then I have 20 newtons multiplied by 5 meter again going in clockwise direction, so I have taken it as negative. And I have force T which is going this way, which is going, sorry, these two forces are anti-clockwise, this is clockwise, so I have taken clockwise as positive, these two as negative, from which I will get T equal to 90 kilonewton. Once I have got T, I solve it for summation Fx equal to 0, from which I will get the force Ex. And from summation Fy equal to 0, for the complete truss, I get Ey equal to 10 Newton, which is a simple thing which you have already done in your simple beam chapter. Then I need to solve first of all joint A, because I told you you have only 2 components which are unknown and there is one applied load which is known to us. So I apply summation Fy equal to 0 at joint A. Now you see for Fy we have a downward going force as 30 kilonewton which is taken as negative, And if I consider the upward going force, I have component of AB in vertical direction along the y-axis, which will be going upward, so I have taken that as positive. Now the angle is given with respect to horizontal here, so the vertical component becomes again the sine of the angle. So FAB into sine of 60, or AB into sine of 60 minus 30 is equal to 0. That gives me AB equal to 34.6 kilonewton tension. Why do I say again tension? Because I have assumed it to going away from the joint, and I have got my answer to be negative or positive. So I say that my assumed direction is correct. Then at the same joint I am applying summation Fx equal to 0, where I have summation Fx equal to 0 as the horizontal component of force AB, that is cos component of AB, that is AB into cos of 60. This is going from left towards the right, so I have considered that to be positive, and I have assumed AC to be going from right to left, so it is negative. So from which I will get AC equal to 17.32 kilonewtons, which is compression. That gives me that the assumed direction which I have assumed is again correct. Once I have done that, I then move on to joint B as seen in the figure previously, and at joint B I have AB force, which I have already known, which is at an angle of 60 degree, and I have member BD and member BC again at angles 60 degree only. If I want to write down FBC for this joint B, if I write down summation F phi, then I get BC cos of 30 as the vertical component minus 34.6 cos of 30, which is equal to 0, from which I will get my FBC, which is again coming out to be positive. So whatever I have assumed that is going towards the joint is correct, and it is under compression. Now if I write down summation Fx, I get FBD again going from left to right, which is positive, minus 34.6 sine of 30 minus 34.6 sine of 30 for both these cases, from which I will get FBD equal to 34.6 kilonewton tension, which is again positive because I have assumed my direction to be going away from the joint only. Then next I come down to joint C. Now if you see at joint C, we have 1, 2, 3, 4 members coming together, but of which we have already solved 2 of the members, that is member AC, which we are known as 17.32 kilonewton, and joint member BC, which is giving me a value of 34.6 kilonewton. So I have basically only member CD to find out in force,